Hey everybody, like I said, I'm not here today and obviously you can tell that, but I'm going to give you the notes for today anyways. So make sure to have a piece of paper out. And if you guys want to start writing this down, it's 2.4a notes, solve an equation with the variable on both sides. That's what you'll be able to do. And you can obviously pause and play this whenever you want. So you can stop and start it. And if you have any questions about what we're doing, just send me an email and I will do my best to get back to you. So this says, sometimes we'll see a variable on both sides of the equation. So this is kind of like our quiz. What we had on our quiz is we only had like the variable on either the left side or the right side. But sometimes we'll see problems where we have it on both sides. And so we need to know how to deal with that. So when this happens, what we'll do is we will move the variables so they're on the same side. So if there's a variable on the left side and the right side, we'll move one to be with the other, or vice versa. We'll move a variable to the right or to the left side. And then we'll basically solve like normal. So for example, 1, notice that on the left side, there is a 3x and on the right side, there's a 2x. And so we have to get those together in order to solve, in order to find the value for x. So I'm gonna give you a second, and I think you're writing all of this down. So this might take you a lot longer. So feel free to pause. And I have two options here. I can either move 3x to the right side, or I can move 2x to the left side. Either way, you'll get the right answer in the end, but there is I would say, a better strategy to do. And my strategy is I never want to have negative x values. So for this one, if I subtract 3x on both sides, I'd have 2x minus 3x, which is a negative x. So I don't like that. So instead, I'm going to subtract 2x on both sides. When I do that, I'll get 3x minus 2x, so I'll get x plus 12. 2x minus 2x is 0 plus 1. And notice when I subtract 2x on both sides, I'm only subtracting it by its like term. So 3x and 2x's are like terms because they both have x's. But like 12 and 1, I'm not going to subtract 2x from 12 because 12 doesn't have any variables in it, so we can't combine those. So this ends up being x plus 12 equals 1. Those are the same thing. And now this is like a basic solving one-step equation problem. So I have x plus 12 equals 1. I want to get x all by itself on the left side. And so I will do the opposite of addition to get rid of the plus 12, and I will subtract 12 on both sides. And I'll get x equals negative 11. And that is our answer. So I'm going to pause for a second here. I want you to think about that. Write any questions. Okay, so next one. So think about real quick before I tell you, which is it easier to move 5x to the right side or is it easier to move 6x to the left side? So think about that. So I personally think it's easier to move 5x to the right side. So I'm going to subtract 5x on both sides. And again, the reason it's easier is because that leaves me with a positive x. And we love positive x's. I know you guys don't like negative numbers. Then I have x minus 10, so x isn't by itself yet. So I'm going to add 10 on both sides to get there, and I'll get 19 equals x. And that is my answer. So pause that if you need more time. I'm going to go to the next one. So we're going to solve t. What I'm going to do is I'm going to add 5t to both sides because since it's negative 5t, I know that if I turn it into addition, I'll get a positive on the left side. So I'm doing 3t plus 5t, which is 8t. 8t plus 13 equals 21. Now this is a two-step problem, so it's a little bit more complicated. And this is when we need to think of reverse order of operations. So the first thing we do when we reverse or we do order of operations backwards is we subtract 13 on both sides. And that's because we get rid of addition and subtraction first in reverse order of operations. So I'll get 8t equals 8. 8 and t are connected by multiplication. So that's what you do. You get rid of multiplication second in reverse order of operations. So I divide both sides by 8. And I'll get t equals 8. If you need more time, pause, but I'm going to move on. Over here, I am going to subtract 2t on both sides because that will give me a positive t value in the end. So on the left side, that would leave me with 5. On the right side, that would leave me with 5t. And then leftover is minus 15. Reverse order of operations. So first I want to get t by itself on the right side alone. So reverse order of operations tells me I'm going to handle the addition and subtraction first. So I'm going to add 15 on both sides. And I'll get 20 equals 5t. Then reverse order of operations says I will undo the multiplication. So I will undo it by doing division. And I'll get 4 equals t. Okay, I don't know why I paused there. We're only going to do C because I didn't get further than C with any of my other classes, but we want to get the B's together. However, the B's are locked in a fraction. And so in order for the B's to go away, we want to get like the fraction and the division to go away. So the way we get the fraction of the division to go away is we multiply by these denominators. So I could either multiply both sides by 4 or multiply both sides by 2. I'm going to choose 4 because it's the bigger number, and hopefully that will make everything work out. So I'm going to multiply both sides by 4 just to get the division to go away first, and then I'll try to combine the b's. So I'm going to do 4 times b minus 6 over 4 equals b over 2 times 4. And I'm going to turn these 4s into 4 over 1 just so like we know exactly what we're doing here. These 4s are in common over here. So since like the greatest common factor between these 4s is both 4, I can cross them out. And then on the right side, the greatest common factor between 4 and 2 is 2. So I do 2 divided by 2, which is 1, and then 4 divided by 2, which is 2. And then I'll just multiply everything up and clean it up. So on the left side, I'm left with b minus 6. And on the right side, I'm left with b times 2, which is 2b, and then 1 times 1, which is 1. And that really just equals b minus 6, which equals 2b. We're almost at the answer, but like I said, we have to get the b's together still. So now we're in a place where we actually can get the b's together. So I'm going to move this left b over to the right b. So I'm going to subtract b on both sides, and I'll get negative 6 equals b. And that is the notes for today. So if you need any help on that, let me know. From at this point, you can do your homework. So it's homework, or you can work on test corrections. So the homework is pages 92 and 93. And you can get caught up on old homework if you don't have that, or you can work on something for another class. But like I said, email me if you have any questions. Miss you guys. I locked away my cactus, so you can't get it. Sorry about that. Okay, bye.